If you could move at the speed of light, about 300,000 kilometers per second, you'd be faster than anything you've ever imagined. Faster than any rocket. Faster than any signal we can send. Faster than the fastest particle accelerator beams. At that speed, you cross the distance from Earth to the Moon in just over a second. You cross Earth's diameter in a fraction of a second. You could circle the planet more than 7 times in 1 second, and still, it wouldn't be enough. Because the numbers we're about to touch don't belong to the human mind. They belong to a universe that was never designed to be intuitive. The observable universe, the portion of reality whose light has had enough time to reach us, is about 93 billion light-years across. That number already sounds impossible, but let's translate it into something even more unsettling. Even if you moved at light speed, it would take you 93 billion years to cross it. That's not a typo. Not millions. Not billions. 93 billion. And here's where your brain tries to rescue itself. Okay, but if I had infinite time, I could still do it. No, because of the catch, the one that turns this from big into existential. The universe is expanding, not like debris flying outward from a central explosion, but in a much stranger way. Space itself is stretching. And on the bigger scales. That stretching means distant galaxies can become unreachable forever. Imagine you're running on a treadmill that accelerates while you run. No matter how hard you sprint, the belt speeds up. The finish line isn't just far, it's moving away. That's what the universe does to you on cosmic scales. So you can chase the edge forever, and the edge will keep sliding away. You never arrive. You never finish. Not because you're weak, because the map is rewriting itself while you travel. Now let's make it feel real. Picture yourself in a ship with perfect shields, perfect fuel, perfect control. No aging, no failure. You launch into the dark and aim for the edge. At first, everything looks normal. Stars thin out, galaxies become smaller, redder, more distant. You're moving through a universe that still looks alive. But as time passes, something begins to happen that feels like a curse. The horizon pulls away faster than you can close the distance. Galaxies don't explode. They don't die. They simply fade. Not because they stop existing, but because the light they emit can no longer catch up to you. One by one, whole islands of reality slide beyond your future, and then comes the truly horrifying image. You're still flying. You're still moving at the fastest speed the universe allows. You are literally the definition of maximum possible motion. And yet the universe becomes quieter, emptier, darker. Eventually, the sky thins. The last distant clusters disappear. The background glow of the cosmos dims. You don't reach an edge, you reach loneliness. A cold, silent, perfectly black ocean where the concept of destination stops making sense. This isn't fantasy. It's a consequence of real cosmology, a universe where distance can grow faster than a beam of light can cross it. Not because the beam is slow, but because space itself is changing under your feet. And this is why tonight's journey matters. Because when you look at the stars, your brain says, the universe is full. But the truth is the opposite. The universe is mostly emptiness. And even the parts we can see are only a temporary privilege. We are alive at a rare moment. A moment where the cosmos still shows us enough light to understand its story. But that story is running away. So let's begin the journey properly. Not from the edge, but from where you are right now. Let's start at the most ordinary place imaginable. Your room. The floor under you. The air around you. The sound in your ears. The quiet assumption that you are still. That stillness is an illusion created by shared motion. At this exact moment, Earth is spinning. If you're near the equator, you're moving at around 1,670 kilometers per hour just from rotation alone. Even far from the equator, you're still moving fast. You just don't feel it because everything around you shares the same spin. And Earth isn't just spinning. It's orbiting the Sun at about 107,000 kilometers per hour. And the Sun isn't resting either. The whole solar system is drifting around the Milky Way at roughly hundreds of kilometers per second. So your stillness is actually a layered storm of motion. You live inside a set of nested orbits, like gears inside gears, and the only reason you feel calm is because you're locked into the machinery. Now, zoom out. The atmosphere, the air that makes your voice possible, is shockingly thin compared to Earth size. If Earth were a basketball, the breathable part of the atmosphere would be like a thin skin you could almost wipe off with your thumb. This matters because it reveals something brutal. Life is not the default state of the universe. Life is a fragile exception protected by a thin membrane. Now step upward beyond that membrane. The sky darkens. The blue disappears. The sun becomes harsh. Shadows become sharp. Temperature becomes strange. Searing heat in sunlight, freezing cold in shade. Because in vacuum, there is no air to carry warmth. Now look back at Earth. At first it still seems huge. A world. A home. But keep going, soon continents blur. Oceans merge. The whole planet becomes a bright marble. And then, the moment that rewires your brain, Earth becomes a dot. A blue-white dot in a black field, and the dot is not centered. It's not special. It's not the stage. It's just one moving piece in an enormous darkness. Now past the moon. He moon feels close to us. But it's already far enough that light needs a little over a second to travel between us. That means every time you look at the moon, you are looking at the past, and that's a theme that will haunt this entire journey. To look far is to look back in time. The night sky isn't a picture. It's a fossil record made of photons. Now imagine leaving the entire Earth-Moon system behind. It becomes one point among many. You realize something unsettling. Our planet has a name. Most things in the universe don't. Our world feels important because we live on it. But on the cosmic map, it is not a main character. It's one warm grain of sand in a desert so big that the concept of desert becomes meaningless. And once you truly feel that, you begin to understand what the universe really is, not a place designed for you, but a place you happen to awaken inside now. The next step is the one that breaks the school diagram in your head. Because the solar system you are shown is not real scale. It's a lie your brain tells itself so it can sleep. Let's expose it. In every classroom diagram, the planets look like neighbors. A neat line. Little spheres. Comfortable distances. That picture is useful for names. But it's emotionally false. In reality, the solar system is not a collection of planets. It's a vast volume of emptiness with a few scattered objects moving inside it. The first distance to break you is the simplest one. Earth to the Sun, it's about 150 million kilometers. Your brain hears 150 million and nods politely, but it doesn't feel anything. The number has no texture, so let's give it texture. If you drove to the Sun at 100 kilometers per hour, no stops, no sleep, no food, it would take about 171 years. That's 2 centuries of non-stop driving, just to reach the star that lights your morning. Now think about Neptune. Neptune is about 30 times farther from the Sun than Earth is. That means about 4.5 billion kilometers away. By car, that's roughly 5,000 years. When you began the trip, ancient civilizations wouldn't even exist yet. When you arrived, entire languages would have been born and died 1,000 times, and that's still not the end, because the solar system doesn't end where the planets end. Beyond Neptune lies the Kuiper Belt, an outer graveyard of icy bodies, and beyond that, the Oort cloud, a spherical shell of comets. That may extend up to 100,000 astronomical units from the Sunday. 1 astronomical unit is the Earth-Sun distance. Yes, the outer boundary of our solar system could be 100,000 times farther than our orbit. If Earth to Sun is 171 years by car, then to the edge of the Oort cloud it would be on the order of millions of years. Let that hit you. Our solar system, the thing we instinctively call home, might be so large that driving to its edge would outlast the entire history of human evolution. And yet, even that is microscopic compared to what comes next, because the next step is the gap between stars, and that gap is not just bigger. It is a different kind of distance, a distance that turns travel into mythology. Before we go there, here's one more mental weapon. Imagine shrinking the solar system down that if the Sun were the size of a basketball, Earth would be a peppercorn. But not sitting next to it. it would be several meters away. And Neptune, much farther. And the Oort cloud, a boundary so distant that the model becomes absurd. The lesson is simple. Space is not filled with things. Things are rare. Space is mostly space. Now we are ready for the truly brutal scale. Stars. Because once you understand how far the nearest star is, you stop thinking of space as a big place. You start thinking of it as an isolation machine. The nearest star to the Sun is Proxima Centauri, about 4.24 light-years away. That sounds manageable until you translate what a light-year actually means. A light-year is not time, it's distance. It's the distance light travels in 1 year at 300,000 km/s. That's about 9.46 trillion kilometers. Now multiply that by 4.24. Even writing the number becomes ridiculous. But again, numbers don't scare the brain. Stories do. So imagine a car. At highway speed. Driving to Proxima Centauri would take tens of millions of years, long enough that the continents would move, climates would shift, species would appear and vanish. Human history is about a few thousand years. This trip would take so long that your entire species would be an invisible microscopic event in the timeline. Now here's the part most people never think about. Even in our region of the Milky Way, the average distance between stars is about 4 to 5 light-years, so Proxima Centauri isn't a weird exception. It's normal. Stars are lonely. The galaxy is not a dense forest of suns. It's a near-empty ocean where suns are scattered like rare boys. Let's use the orange analogy, because it hurts in the best way. If the sun were an orange about 10 centimeters wide, then the nearest star orange would be roughly 3,000 kilometers away. 1 orange in one huge city. 1 orange in another city. And between them? Nothing. No atmosphere. No wind. No sound. Just vacuum and darkness. That's what space between stars really means. It isn't distance. It's separation. And in that separation, the universe becomes psychologically different. Because separation means isolation. Isolation means survival is hard. And survival means the universe doesn't care whether you exist. Now imagine standing in interstellar space. No Sunday. No Earth. No bright sky. Stars are points. The nearest one is a distant needle. There is no up or down. No horizon. Just a black sphere around you. Your brain would start doing something terrifying. It would search for reference points. Because humans are built for landscapes, trees, mountains, walls, ceilings. Interstellar space has none of that, so the mind turns inward. Time stretches. Silence becomes loud. This is why deep space is not just a physics problem. It's a psychological problem. Now scale up again, from stars to the Milky Way, because if star distances isolate you, the size of the galaxy destroys the idea of crossing anything at all. There is a barrier in cosmology that isn't made of metal, stone, or force fields. It's made of physics. It's called the cosmic horizon, the limit beyond which information can never reach us. This is the ultimate you can't go there sign, not because we haven't invented a strong enough engine, but because the universe may be built so that certain regions are permanently disconnected. Here's the nightmare logic. Light has a maximum speed. The universe has a finite age. Space expands. Therefore, there are places so far away and being carried away so fast by expansion that their light will never arrive here. That means some galaxies, right now, are already beyond the future of your eyes, even if humanity survives for 1 billion years. Even if we build impossible telescopes. Even if we become post-human, machine, immortal. Whatever, some places will remain forever outside our story. So when people say the universe, what they usually mean is everything. But what science actually gives us is everything we can, in principle, ever observe. Outside that, possibilities without proof. And yes, that includes all the strangest thoughts, regions with different physical constants, different forms of matter, different dimensions, entire other bubble universes from cosmic inflation models. or simple endless continuation of the same thing forever? The uncomfortable truth is, we don't know. And we might never know. Now here's the most haunting part, the one that makes this a horror story told by astronomy as time goes on. The horizon doesn't just exist, it consumes. More galaxies drift beyond it. The observable universe becomes a smaller fraction of reality. In the very distant future, intelligent beings in our galaxy might look up and see almost nothing. No other galaxies, no cosmic background glow, no evidence that the universe was ever larger than their local region. They would live in a cosmic prison without bars. They wouldn't even know it's a prison. They'd make the same mistake we make when we look at classroom diagrams. They would think the cosmos is small because they can only see a small part of it. And that loops us back to the opening thought. Even if you run at the fastest speed possible, you don't reach the edge. You chase a horizon that retreats forever. The universe isn't a map with borders. It's a story with limits on what you're allowed to read. By now, it feels like we've already seen everything there is to see. Stars, galaxies, distances so vast they break intuition. But here's the first brutal truth that rewrites everything. Everything we've talked about so far, all stars, all planets, all galaxies, is only about 5% of the universe. 0.5%. That means 95% of reality is invisible to us. Not metaphorically invisible. Literally invisible. No light, no reflection, no emission, no absorption. Nothing your eyes, or even your telescopes, can directly see. This invisible majority comes in two forms. The first is dark matter. We know it exists because galaxies shouldn't behave the way they do. When astronomers measure how fast stars orbit the centers of galaxies, the math doesn't work. The visible matter isn't enough to hold galaxies together. According to known physics, they should tear themselves apart. But they don't. Something unseen adds gravity. Something massive surrounds galaxies like an invisible halo. Dark matter doesn't interact with light, but it bends space. It shapes galaxies. It forms the scaffolding on which visible matter hangs. Right now, trillions of dark matter particles are passing through your body every second. They don't harm you. They don't notice you. You are moving through a ghost ocean. And then there's dark energy. The most unsettling concept of all. Dark energy isn't matter. It doesn't clump. It doesn't form structures. It fills space itself. And it's the reason the universe's expansion is accelerating, not slowing down. Not stabilizing, accelerating. Something is pushing space apart faster and faster over time. We don't know what dark energy is. We don't know where it comes from. We don't know if it's constant or evolving. All we know is this: if dark energy continues to dominate, then the universe's future is one of increasing isolation. Galaxies drift away. Communication becomes impossible. The cosmic night grows deeper. So pause for a moment. Everything you've ever loved, everything humanity has built. Every star you've ever seen. All of it floats inside a reality where most of what exists is unknown, unseen, and fundamentally mysterious. And this isn't a failure of technology. It may be a limit of existence itself. You might wonder, how do we even know these distances are real? After all, we can't stretch a tape measure across space. We can't send probes to other galaxies and wait billions of years for a signal back. So how do we measure the universe? The answer is something called the cosmic distance ladder, a chain of methods, each relying on the previous one. It starts close. The first rung is parallax, the same effect you can test right now. Hold your finger in front of your face. Close one eye, then the other. Your finger appears to shift relative to the background. Astronomers do the same thing using Earth's orbit. In January, Earth is on one side of the Sun. In July, it's on the other. That baseline is 300 million kilometers wide. By measuring how nearby stars shift against distant ones, we calculate their distance. This works, but only locally. Beyond a few thousand light years, the shift becomes too small to detect. So we move to the next rung. Standard candles. These are objects whose true brightness we understand. If you know how bright something really is, and how dim it appears, you can calculate its distance. One of the most important standard candles is the Cepheid variable star, stars that pulse in brightness at regular intervals. Their pulse period is directly related to their true luminosity. This discovery allowed Edwin Hubble to prove that Andromeda is not part of the Milky Way, but a galaxy of its own. For even greater distances, we use type Ia supernovae, stellar explosions so powerful and so consistent that they act like cosmic flares visible across billions of light years. And it was these supernovae that revealed something shocking in 1998. The expansion of the universe is speeding up. That discovery earned a Nobel Prize and forced us to accept dark energy. Every rung of the ladder extends our vision further, but also reminds us of something uncomfortable. We are inferring reality, not touching it. We don't see the universe directly. We reconstruct it from fading light and mathematical ghosts, and yet it works. The universe is stranger than we imagined, but consistent. At first glance, the universe looks surprisingly uniform. No matter where we look, the laws of physics appear the same. The temperature of the cosmic background radiation barely changes from one direction to another. This seems natural, but it isn't, because many regions of the universe are so far apart that they could never have exchanged information. Light simply didn't have enough time to travel between them, and yet they look synchronized, balanced, coordinated. So physicists proposed a radical idea: cosmic inflation. A moment, incredibly brief, when the universe expanded faster than anything we observe today. Not over millions of years, not over seconds, but in a fraction of a second, so small that time itself almost loses meaning. During inflation, space stretched violently. Distances multiplied exponentially. Quantum fluctuations were frozen into cosmic structure. Before inflation, everything we can now observe may have fit into a region smaller than a single atom. Pause for a moment and let that sink in. Everything you see in the night sky, every galaxy, every star, every planet once existed inside something smaller than dust, and inflation didn't just make the universe big, made it flat, uniform, and predictable. But inflation comes with a disturbing implication. In many models, inflation doesn't end everywhere at once. It stops here, but continues elsewhere. Those other regions inflate into other universes, not distant galaxies, not parallel timelines, entire universes, each sealed off forever, each unreachable, each possibly governed by different physical constants. Pause. This is not philosophy. This is mathematics. Some universes might collapse instantly. Others might never form stars. Some might have no chemistry, no atoms, no time as we understand it. We exist in a universe where the constants happen to allow structure, not because it was designed for us, but because only such universes can produce observers. This idea is deeply unsettling. It suggests that our universe is not special. It is merely one bubble among countless others, and we will never know how many exist. Or if this explanation is correct at all, inflation solves some problems, but creates even deeper ones. And beyond this point, science grows quiet. Space feels calm, silent, still, but this calm is deceptive because the universe is not gentle. It is violent on a scale that makes all human conflict irrelevant. Stars are not stable lamps. They are pressure balance bombs for millions or billions of years. They resist gravity until suddenly they don't. When massive stars die, they explode as supernovae. In seconds, they release more energy than our sun will emit in its entire lifetime. Pause. These explosions forge heavy elements: iron, gold, uranium. Every atom heavier than hydrogen was born in catastrophe. Your blood contains iron forged in a stellar death. Your bones contain calcium created in cosmic violence. Life itself is a byproduct of destruction, but supernovae are only the beginning. There are gamma-ray bursts, brief flashes of pure energy so intense that, for a moment, they outshine entire galaxies. They last seconds, but if one were to strike Earth from within our galaxy, it could strip away the ozone layer and sterilize the surface, pores. Then there are black holes, not empty holes. Not cosmic vacuum cleaners, but regions where space-time collapses in on itself. When black holes collide, space-time ripples outward at the speed of light. In 2015. Humanity detected these ripples for the first time for a fraction of a second. Two merging black holes released more power than every star in the observable universe combined. Pause. This violence is not rare. It is constant. Across the universe, stars explode. Black holes merge. Galaxies collide. Life exists only because, for brief moments, in rare locations, violence pauses long enough for complexity to emerge. We are not protected, we are simply lucky. The universe has a beginning. It has a middle, and it has an ending, not a dramatic ending. Not an explosion, but something far colder. Yes, the universe expands. Stars burn out. Galaxies fade. Matter becomes locked in remnants. Pause. In the far future, star formation stops entirely and no new light is born. Only aging stars slowly die eventually. Even the smallest red dwarfs exhaust their fuel after tens of trillions of years. The last stars go dark. Pause. What remains are corpses, white dwarfs, neutron stars, black holes. Planets drift frozen through darkness. Galaxies become graveyards, and time continues, but nothing happens longer. Pause. If protons decay, and many theories suggest they do, then even atoms fall apart, matter dissolves, structure disappears. After unimaginably long spans of time, only black holes remain, and even they are not eternal. Through Hawking radiation, black holes slowly evaporate. The smallest vanish first. The largest take longer than the current age of the universe raised to absurd powers. Pause. When the last black hole evaporates, there is no explosion. No light. No sound. Only a universe filled with thin, cold radiation. No gradients. No structure. No possibility of change. This is heat death. A state where nothing meaningful can ever happen again. Longest pause. Time continues, but there is no future. There is a moment in every journey through the cosmos when distance stops being a number and becomes a feeling, not kilometers, not light years, but a quiet pressure on the mind. We have traveled outward from Earth, past the planets, past the stars, past the spiral arms of the Milky Way. We have crossed galaxy clusters, superclusters, filaments stretching across billions of light years. And now we stand at the edge of everything we can ever see. This boundary is called the observable universe. It is not a wall. It is not an edge you could touch. It is simply the limit of information. Light has a speed. Time has a beginning. And because the universe is 13.8 billion years old, there is a maximum distance from which light has had enough time to reach us. That distance is about 46 billion light years in every direction, which means the observable universe is a sphere, centered on you not because you are special, but because observation always centers on the observer. If someone were standing on a planet in a distant galaxy, their observable universe would also be centered on them. Two observers, two spheres, overlapping but never identical already. This should unsettle you, because it means there is no single observable universe. There are countless ones, and beyond the edge of yours, reality continues without you. When we look at the most distant galaxies with telescopes like James Webb, we are not seeing them as they are now. We are seeing ghosts, ancient light emitted when the universe was young. When galaxies were smaller, denser, more violent, some of those galaxies may no longer exist. Some may have merged, collapsed, or faded into darkness, and yet their light still travels, crossing expanding space, arriving at our eyes billions of years later. This is one of the strangest truths of cosmology. The farther you look, the further back in time you see. There is no way to see the universe as it is now on large scales. The present is local. The past is cosmic, and the future is unreachable. Now comes the truly disturbing part. The observable universe is not static. It is shrinking, not in physical size, but in what will ever be visible, because the expansion of the universe is accelerating, driven by dark energy. Space itself is stretching faster and faster. Distant galaxies are not merely moving away, the space between us and them is growing. Some galaxies are already receding faster than the speed of light. This does not violate relativity, because they are not moving through space faster than light. Space itself is expanding, and anything beyond a certain distance is crossing a point of no return. This boundary is called the cosmic event horizon. Light emitted beyond it today will never reach us, not tomorrow, not in 1 trillion years. Never. Those galaxies still exist. They still shine. But for us, they are already gone. Every second, more galaxies slip beyond this horizon. Every second, the accessible universe becomes smaller, quietly, relentlessly. No explosion. No warning. Just lost. In the unimaginably distant future, all galaxies outside our local group will vanish from view. The night sky will change. Future astronomers, living trillions of years from now, will look up and see only one galaxy. Their OWN.NO cosmic microwave background. No distant clusters. No evidence of expansion. To them, the universe will appear static, small, eternal. Cosmology itself will be impossible. They will not know the universe had a beginning. They will not know it was once filled with galaxies. They will live inside a cosmic illusion, created by the limits of light and time. We are lucky we exist at a moment when the universe still reveals its past, when the evidence has not yet faded beyond reach. This moment will not last forever, and that alone gives our era a quiet, tragic significance. But even this is not the end of the story, because the observable universe is only a fraction of the total universe. How large is the universe as a whole? The honest answer is simple. We do not know. We can measure curvature. We can analyze cosmic background radiation. We can test models, and so far, everything suggests one unsettling possibility. The universe is either vast beyond imagination or truly infinite. If the universe has any curvature at all, it is so slight that the total size must be at least hundreds of times larger than what we can observe. And if it is perfectly flat, then it may extend forever. No center, no edge, no boundary. An infinite expanse of space, with infinitely many galaxies, infinitely many stars, and perhaps infinitely many versions of familiar patterns. This idea breaks intuition. Infinity is not something the human brain evolved to handle, but the universe does not care about intuition. Reality is under no obligation to be comfortable. At first glance, the universe looks chaotic. Stars scattered randomly, galaxies drifting aimlessly, violence and emptiness mixed without order. But when astronomers began mapping the cosmos on the larger scales, a hidden structure emerged. The universe is not a random cloud. It is a cosmic web. Vast filaments of galaxies stretch across hundreds of millions of light years. They intersect at dense nodes, galaxy clusters. Between them lie enormous voids, regions so empty that entire galaxies are rare. This structure did not arise by chance. It is the result of gravity, working on tiny fluctuations present in the universe's earliest moments. Slight differences in density, one part slightly heavier than another, were amplified over billions of years. Matter flowed toward matter. Voids grew emptier. Filaments grew thicker, and over cosmic time, this invisible skeleton emerged. But here is the crucial point. Most of this structure is invisible. The glowing galaxies we see are only markers. The true architecture is built from dark matter. Dark matter does not emit light. It does not absorb light. It passes through ordinary matter almost without interaction, and yet it outweighs visible matter by a factor of about 5 to 1. Without dark matter, galaxies could not form, stars would never have gathered, planets would not exist. Life would be impossible. Dark matter is the unseen scaffolding that holds the universe together, and we still do not know what it is. Particles? Fields? Something even stranger? We detect it only through gravity, through the way it bends light, through the way it shapes cosmic motion .it surrounds every galaxy, including our OWN.it passes through your body right now, billions of particles per second, leaving no trace. The universe is not just stranger than we imagined, it is stranger than we can imagine. And then there is dark energy. If dark matter builds structure, dark energy erases it. Dark energy is not clumped. It does not gather. It fills space uniformly, and as space expands, dark energy does not dilute. It becomes more dominant. This means that over time, the expansion of the universe accelerates, not slows. Accelerates. Galaxies drift apart faster and faster, until gravity can no longer bind new structures. Star formation declines. Galaxy mergers end. The universe grows quieter, colder, more isolated. This is not a dramatic apocalypse. It is a slow fading. A dimming of complexity, the long, gradual silence of cosmic history. Yet even in this fading universe, there is something extraordinary. For a brief window of time, a window measured in billions of years, conditions allow complexity. Stars burn steadily. Elements heavier than hydrogen form. Planets assemble. Chemistry becomes rich. And in rare places, matter becomes aware. Consciousness emerges not as a fundamental force, but as an accidental arrangement. A temporary pattern in an uncaring universe. And yet, that pattern is capable of understanding the universe itself. Of tracing its origin, of predicting its fate, of standing at the edge of observable reality and asking questions. No star can ask, this is not small. It only feels small. Because the universe is vast, but vastness does not diminish meaning. It reframes it. *** when we talk about the universe. We usually speak in terms of distance. Light years, parsecs, billions upon billions of kilometers, but distance is only half of the illusion, because time is far deeper than space. Space can be crossed, at least in principle. Time cannot. Every place in the universe exists now only locally. Everything else exists in the past. When you look at a star 10 light years away, you are not seeing where it is, you are seeing where it was, and the further you look, the more ancient the light becomes. This means the universe is not a snapshot. It is a layered archive. A geological record of reality itself. Closer objects are recent pages. Distant galaxies are fossilized chapters written billions of years ago. At the extreme edge of observation, we see the universe as it was shortly after birth, not stars, not galaxies, but plasma. A hot, opaque fog of particles and radiation. This is the cosmic microwave background, the afterglow of the Big Bang, light that has been traveling for 13.8 billion years just to reach us. And yet, even this ancient light does not show us the beginning. It shows us a moment after the beginning, because before that, the universe was opaque, too hot for atoms, too dense for light to move freely. There is a wall in time. We cannot see past it, not because our telescopes are weak, but because physics itself forbids it. The earliest observable moment is about 380,000 years after the Big Bang. Before that, the universe is hidden behind a veil. A horizon not of space, but of time. This raises a disturbing question. If we cannot see the beginning, how do we know it happened? The answer is indirect. We see expansion. We see cooling. We see the abundance of light elements. We see patterns frozen into background radiation. All signs point backward to a hotter, denser, smaller state, but that state is not a point in space. It happened everywhere at once. The Big Bang was not an explosion into empty space. It was the expansion of space itself. There was no center. No edge. No outside. Every point was the center. Everywhere was the origin. This is one of the hardest ideas to accept. There is no privileged location. No cosmic landmark. The universe expands equally from every point. And yet, even this is not the deepest layer of time, because our equations break down before the earliest moments. At extremely high energies, gravity and quantum mechanics collide, space and time lose meaning. The laws we rely on dissolve. This is called the Planck era. A fraction of a second after the beginning, shorter than anything we can measure, and beyond that, we do not know. Not we don't know yet. We may never know, because knowledge itself depends on structure, on time, on causality, and those concepts may not apply. Before the universe stabilized, time itself may have begun with the universe. Or it may have existed in some form we cannot describe. The question, what happened before the Big Bang, may be meaningless, like asking what is north of the North Pole, and yet humans keep asking because curiosity does not obey boundaries. Some theories suggest a cyclic universe, expansion followed by contraction, a big crunch, a rebirth. Others suggest a multiverse, where inflation creates endless pocket universes. Others suggest that our universe emerged from a quantum fluctuation in a timeless vacuum. All of these ideas are mathematically possible, none are confirmed, and that uncertainty is not a failure. It is a reminder. The universe is not obligated to be fully knowable. There may be truths forever beyond reach, and we must learn to live with that. Against this backdrop of scale, time, and cosmic indifference, human existence seems almost absurd. A species that lives less than a century trying to comprehend processes that unfold over trillions of years. A mind evolved to hunt and gather, attempting to grasp infinity, and yet this very contrast creates meaning. Meaning does not come from permanence. Nothing in the universe is permanent. Stars die. Galaxies disperse. Even black holes evaporate. Meaning comes from experience, from awareness, from the brief moment when matter looks back at itself and asks questions. Life is not significant because it lasts. It is significant because it happens at all. Out of all the possible arrangements of matter, almost all are lifeless, almost all are silent, almost all will never think, and yet here we are, temporary, fragile, aware. This awareness carries a burden. To know that everything ends. To know that the universe itself has an expiration. To know that even if humanity survives for millions of years, it cannot escape cosmic fate. There is no refuge from entropy. No ultimate shelter. No final victory. And yet, this does not make life meaningless. It makes it precious. Every moment of understanding is borrowed against oblivion. Every act of curiosity is a rebellion against silence. Every question asked is a spark in the dark. The universe does not give meaning. We create it, not through dominance, not through conquest, but through attention, through looking, through listening, through remembering. When you look at the night sky, you are not just observing stars, you are participating in a chain of causality that began billions of years ago. Photons leave a distant galaxy. They cross expanding space. They strike your retina. They trigger neurons, and in that instant, the universe becomes aware of itself in a new configuration. That moment will never happen again, not in that way, not in that place, not with that observer, and when it ends, it is gone forever, but while it exists, it is real. That is enough. There is a misconception about space. People imagine explosions, violence, endless motion, but the dominant feature of the universe is not energy. It is silence. Between stars, silence. Between galaxies, deeper silence. Between clusters, a silence so complete that even a single atom becomes a rarity. If you were placed in the average region of the universe, you would not see stars, you would not see galaxies, you would see nothing, not darkness caused by shadows, but darkness caused by absence. No nearby light sources, no reference points, just blackness in every direction. This is the true environment of the cosmos. Matter is the exception. Emptiness is the rule. And this emptiness is not passive. It expands, space itself grows, stretching distances, thinning energy, cooling everything toward equilibrium. Entropy increases not through chaos, but through quiet, through diffusion, through dilution. The universe does not explode toward its end. It fades, information spreads out, structures dissolve, temperature differences vanish. This is what physicists mean by heat death, not fire, not destruction. Uniformity. A state where nothing interesting can happen because there are no gradients left and no energy flows. No processes, no change, just space, thin radiation, and particles drifting apart forever. And here is a deeply unsettling thought. The future universe will not Remember us, not because it is cruel, but because memory requires structure. Memory requires matter arranged in patterns, and those patterns will not survive. Even information itself has a lifespan. Black holes were once thought to be eternal. Vaults, places where information disappears forever, but we now know they evaporate. Hawking radiation slowly drains them over unimaginable timescales, and when the last black hole vanishes, even those records are gone. What remains is a universe with no observers, no records, no history. A universe where time still technically exists, but nothing marks its passage. Seconds mean nothing if nothing changes. This leads to a strange conclusion. The universe can exist without experience, but experience cannot exist without structure. Consciousness is not guaranteed. It is not inevitable. It is a rare phase in cosmic evolution. A brief window between chaos and silence. We live inside that window. ******. There is another misconception, that observation is passive, that the universe exists independently of whether anyone looks. At the macroscopic level, this is mostly true. Stars burn whether or not we watch them. Galaxies collide whether or not we record it. But at the deepest level of reality, this assumption breaks down. Quantum mechanics tells us something strange. Observation matters, not metaphorically. Physically. At fundamental scales, systems exist in probabilities, not certainties. Particles do not have definite positions until measured. States do not collapse until interaction occurs. This does not mean the universe needs human observers, but it does mean that interaction defines reality, and observers are specialized interaction engines, conscious systems that process, store, and interpret information. Without observers, the universe still exists, but it exists without meaning, without narrative, without perspective. This raises a profound possibility that consciousness is not an accident, not a cosmic joke, but a natural outcome of complexity reaching a certain threshold. Whenever matter organizes itself enough to model reality, the universe gains a point of view, and with each new observer, reality gains another interpretation of itself. You are not separate from the universe. You are the universe in a configuration that can ask questions. Your thoughts are not outside physics, they are physical processes. Electrons moving, neurons firing, patterns emerging, and yet, from these patterns arises experience, subjectivity, meaning. This is not something we fully understand. We know how brains work in parts. We know how neurons fire. We do not know why experience feels like something, why there is a you inside, why matter arranged this way becomes aware. This is called the hard problem of consciousness, and it may be one of the deepest mysteries in science. Perhaps consciousness is rare, perhaps it is fragile, perhaps most universes, if there are many, never produce observers at all. In that case, we are extraordinarily lucky, not because we exist, but because we notice. We can reflect. We can wonder. We can feel. Or is not weakness, or is the correct response to scale. To infinity. To a universe that does not care yet somehow gave rise to beings who do. ****. There is a limit not only to distance, not only to time, but to information itself. We often think of information as something abstract, data, bits, messages, but information is physical. It requires energy. It requires structure. It requires matter arranged in specific ways, and like everything physical, information is subject to entropy. Over time, order decays, patterns blur, signals fade into noise. This is not a flaw of the universe. It is a consequence of its laws. As the universe expands and cools, it becomes harder to preserve distinctions. Temperature differences disappear. Energy gradients flatten, and without gradients, nothing meaningful can happen. No engines, no computation, no memory. In the far future, even the concept of before and after loses significance. Time still exists mathematically, but there is nothing to mark its passage. No clocks, no processors, no observers, just an endless stretch of uniformity. This has a strange implication. The universe may continue forever, but history will not. There will be a point after which nothing new can be recorded, after which no event can be distinguished from any other. At that stage, even asking questions becomes impossible, not because answers are forbidden, but because the machinery required to ask them no longer exists. This is the true end, not destruction. Not collapse, but forgetfulness. A universe that forgets itself, all stories erased. Not by force, but by dilution, every civilization, every star, every thought eventually dissolved into statistical noise. It is tempting to see this as nihilistic, but it is not, because meaning was never guaranteed by eternity. Meaning exists only while information exists, and right now, information is abundant, structure exists, complexity thrives, the universe is young enough to remember itself. We live in that memory window. There is a limit that few people ever consider, not the limit of distance, not the limit of speed, not even the limit of time, but the limit of information itself. We live in an age where information feels endless. Data streams constantly. Memories are stored, copied, duplicated, backed up. It feels permanent. But on a cosmic scale, information is one of the most fragile things that exists. Information is not abstract. It is physical. Every memory requires matter arranged in a precise way. Every record requires energy. Every signal requires contrast, a difference between states, and the universe is slowly erasing differences. As the cosmos expands, energy spreads out. Temperatures equalize. Structures dissolve. This process is slow beyond imagination, but it is relentless. Over trillions upon trillions of years, stars burn out. Galaxies fade. Black holes evaporate, and with them goes structure. Without structure, information cannot exist. In the far future, there will be no computers. No brains. No crystals holding patterns. No atoms arranged into meaningful forms, just particles drifting through immense cold space. Even radiation will thin out until it carries almost no usable energy. At that stage, nothing meaningful can be recorded, nothing can be remembered. The universe does not end in fire. It does not end in darkness. It ends in indifference. A state where every region of space looks almost exactly like every other, where no event stands out, where nothing leaves a trace. This is sometimes called the heat death of the universe. But that name is misleading. There is no dramatic death, only a slow forgetting. A gradual smoothing of reality until nothing interesting remains, and this leads to one of the most unsettling realizations in cosmology. The universe will outlive its own history. There will be a future where the universe still exists, but no one can ever know what came before. No fossils, no signals, no cosmic background, all evidence erased by time itself. From that perspective, everything that has ever happened, every star, every civilization, every thought, exists only temporarily, not because it is unimportant, but because impermanence is fundamental. Meaning does not come from duration, meaning comes from presence, from happening at all, right now. The universe is still capable of complexity, still capable of memory, still capable of observers. This era will not last forever, and that makes it rare. Asterisk, when people talk about the universe, they often imagine it as crowded with civilizations, crowded with signals, crowded with ancient intelligences watching from afar. This idea is comforting. It suggests that we are not alone, that someone else has already solved the problems we struggle with, that somewhere, someone understands the universe better than we do. But the deeper we look, the quieter space becomes, not empty, but silent, not hostile, but distant, and this silence forces us to confront a difficult possibility. Cosmic loneliness may not be an accident. It may be the natural state of the universe. The universe is unimaginably large, but size alone does not guarantee connection. Distance is only one barrier, time is another. Civilizations do not exist forever. They rise, develop, and eventually disappear. Sometimes through catastrophe, sometimes through stagnation, sometimes through slow decline. even if intelligent life is common. Its overlap may be rare. Two civilizations could emerge in the same region of space separated by tens of millions of years. To the universe. That difference is nothing. To the civilizations themselves. It is everything. B why the time one sends its first radio signal. The other may already be dust. No conversation. No contact. No shared history. Just mischances across time. There is also the problem of scale. Signals weaken as they travel. Energy spreads out. Noise overwhelms meaning. A message sent across the galaxy arrives faint. Distorted. Delayed. B why the time it reaches its destination. The sender may no longer exist, and if the message is received, the response will take just as long to return. Communication becomes meaningless when cause and effect are separated by centuries. To that point. It is no longer a conversation. It is archaeology. Even travel does not solve this problem. Interstellar travel demands energy on a scale that challenges physics itself. Generation ships, hibernation, relativistic travel, all come with costs, biological limits, technological fragility, psychological strain, and beyond a certain point, travel becomes indistinguishable. From exile, you leave everything behind knowing you will never return, not because you failed, but because the universe is too big. This is why cosmic loneliness is not tragic. It is structural. It emerges naturally. From the laws of physics, from the speed of light, from entropy, from expansion. The universe does not isolate civilizations out of cruelty. It isolates them out of indifference. And yet, within that indifference, something remarkable happens. Consciousness appears briefly, locally, fragile, but real. Each thinking species becomes a temporary island of awareness in an ocean of silence. From this perspective, intelligence is not the norm. It is an exception. A rare alignment of chemistry, stability, and time. And that rarity gives it value. If thinking minds were everywhere, they would be interchangeable. If they lasted forever, they would be meaningless. But because they are scarce, and because they are temporary, they matter. Every civilization that arises is the universe briefly becoming aware of itself. Every question asked is a moment where matter reflects on its own existence. Every observation adds texture to an otherwise silent cosmos. This reframes loneliness. We are not lonely because no one is out there. We are lonely because the universe is vast, and awareness is local. Loneliness is not failure. It is a consequence of being early, or late, or simply alone in time. And perhaps this is why curiosity is so important. Curiosity is what prevents awareness from collapsing inward. It pushes outward. It searches. It listens even when there is no response. There is also a darker possibility. Civilizations may not disappear. Naturally, they may destroy themselves. Technology amplifies power faster than wisdom. Energy becomes abundant before restraint does. Weapons evolve faster than ethics. If this happens often, then the universe may be filled with short-lived intelligences, flashes of thought that vanish before reaching maturity, not because survival is impossible, but because balance is difficult. If this is true, then silence is not emptiness. It is aftermath. And yet, even this interpretation does not erase meaning, because meaning does not require permanence. A thought does not become worthless because it fades. A life does not become insignificant because it ends. A civilization does not fail because it is temporary. Duration is not the measure of value. Experience is right now. Humanity exists in a narrow window. We are advanced enough to ask cosmic questions, but not yet powerful enough to guarantee our future. This makes our moment rare and responsibility heavy, because if consciousness is uncommon, then preserving it matters, not just for us, but for the universe itself. Without observers, the universe still functions, but it does not know. It expands. It cools. It evolves, but nothing witnesses it. Nothing remembers. Nothing wonders. In that sense, every conscious being is a guardian of meaning, even if only temporarily, even if alone, even if unheard. The silence of the universe does not diminish us. It magnifies us. because in a cosmos that does not care, caring becomes extraordinary. Asterisk. Asterisk at the end of this journey, after crossing frozen worlds, burning planets, endless darkness, after standing beneath alien skies and impossible storms, we return to a simple truth. The universe does not speak to us. It does not explain itself. It does not comfort us. It does not promise that someone is watching, and yet, it allows us to exist. For billions of years, the universe expanded in silence, stars were born and died. Galaxies collided. Planets formed, shattered, and reformed. All of it happened without witnesses until, on a small and fragile world, matter learned how to look back. Life emerged. Then thought. Then questions, and suddenly, the universe gained something it never had before, perspective. We often ask whether the universe has meaning. But perhaps that question is backwards. Perhaps meaning does not exist within the universe. Perhaps meaning exists because of those who observe it. A mountain is just rock until someone sees beauty in it. A star is just fusion until someone wonders how it was born. A universe is just physics until something inside it begins to care. This is why the silence matters. It forces us to listen to ourselves. A loud universe. Meaning would be given. A silent one. Meaning must be created. Every story we tell. Every equation we write. Every probe we send into the darkness. These are not answers from the universe. They are answers to the universe. Perhaps we will one day find others. Perhaps distant civilizations exist, quiet for reasons we do not yet understand. Or perhaps the universe is mostly empty of thought, and intelligence is a rare spark that appears only occasionally, briefly, before fading away. Both possibilities lead to the same conclusion. What exists now matters. What we do now matters, because consciousness may not be eternal. But while it exists, it changes everything. It turns randomness into curiosity, silence into mystery, distance into wonder, and even if we are alone, we are not insignificant. We are the universe, briefly awake. So when you look at the night sky, remember this: the darkness is not watching you, but you are watching it, and that makes all the difference. This is not the end of the journey. It is simply the moment where the universe pauses long enough to be understood. For a while. Star.